everyone, Richard here. In my previous video on Botticelli's Primavera, I showed you this interesting bit of geometry that formed a rectangle in an unusual double-proof way. As I said in that video, that led me to several more ways to create similar rectangles. I'll show you some of these here, in part because it's interesting geometry, but also because some of these geometries will show up as I explore new paintings. Stay tuned. So, to start, here again is how that first geometry is made. Starting with a pentagon, pentagram, circle, and horizontal lines at the top and bottom, the dimensions of the rectangle are found in two ways. First, by extending the top sides of the pentagon to the same length as the sides of the pentagram, like this. The sides of the rectangle are drawn at the outer tip of those lines. But the sides are also found in another, more unusual way, by extending the sides of the pentagram down until they meet the bottom line, then drawing a line from those points to the upper corners, just touching the sides of the circle enclosing the pentagram. A friend, Anthony Thompson, a retired geometry professor from Dalhousie University in Halifax, has done the math for me. This geometry can be proven. The lines exactly touch the circle. The rectangle created in this way is very near the proportions of 13 by 20, but not quite. Again, Anthony did the math. The ratio of this rectangle is 1 to 1.5388. where the ratio of a 13 by 20 rectangle would be 1 to 1.5385, both rounded off to 4 decimal places. Remarkably close, but not exact. A rectangle with this exact same proportion can be made in at least two other similar but quite different ways. The first one starts with the same pentagon, pentagram, circle, with horizontal lines at the top and bottom. The dimension of the rectangle is established simply by extending the left bottom side of the pentagram, meeting the top line at the left, and extending the right bottom side of the pentagon, meeting the top line at the right. Vertical lines drawn at these 2 points form the left and right sides of a rectangle with the exact same proportions as the previous one. Like the first, the sides also can be found in the peculiar way of, on the left, extending the left side of the pentagon until it meets the bottom line, then drawing a line from that point to the upper corner of the rectangle, exactly touching the side of the circle, and then extending the bottom side of the pentagram down to the bottom, like so, and drawing a line from that point to the upper right corner, again, exactly touching the side of the circle. And, interestingly, a rectangle created in this way places the pentagon, pentagram, circle exactly centered on a golden mean of the horizontal dimension. Another way of making a rectangle with these proportions is to turn the pentagon, pentagram, circle on its side, like this. Then draw lines at the top and bottom, as well as on the right side, touching the edge of the circle and the points of the pentagon, pentagram. Then from that point, extending the sides of the pentagram to the left until they meet the top and bottom line. A line drawn between those 2 points forms the left side of a rectangle with the same proportions as the previous two. And like the previous two, this rectangle can be found in a second way. Fit another reversed pentagon, pentagram over the first, and extend a side of the pentagram to the left until it meets the left side, like so. Then extend this side of the pentagram so that it meets the top line. When a line is drawn from that point towards the left so that it just touches the side of the circle, it meets the first line at the left side of the rectangle. Repeating this on the bottom makes the geometry symmetrical. and turned upright, it looks like this. Variations of these rectangles can be made by combining these geometries in different ways, like these. I find this last one quite interesting, with its main focus just slightly off-center. I'm using it for the composition of two new works. Here's one more somewhat different variation. Extend these lines of the pentagram, down, like this, and they all meet on the same horizontal line. Draw vertical lines on the outer points to form sides. Repeating this on the top forms a rectangle just slightly taller than wide, and with the pentagram circle nicely suspended in the center. One last note. I mentioned in the video about Botticelli's Birth of Venus, Part 4, that a golden rectangle can be made in a similar way, like this. But though it's very close, that's not exactly accurate. A golden rectangle the size of the Birth of Venus is 172.5 by 279.09 centimeters. A rectangle created in this way, with the same height, 172.5 centimeters, would be 279.36 centimeters wide, barely a quarter of a centimeter wider, less than the width of the white outlines here. It's amazing to me that it's so close, but not quite. Geometry has its mysteries. The video I had planned here became unwieldy, so the refresher course on basic geometry and how to construct a golden rectangle and a pentagram has been turned into a separate video, coming up next. For information on my own work, please visit my website at rtdavis.com. You can also find me on Instagram at Richard Thomas Davis Artist. Thanks for joining me.